In this video, we are going to discuss about how a regular expression can be converted to Epsilon NFA. So, before getting into Epsilon NFA, we'll first see what is the NFA. NFA is non-deterministic finite automata, where, as discussed in previous videos, multiple transitions for single input is possible from one state to another. So here in specific in NFA we can have epsilon transitions in the sense empty transitions. For example, here consider there are two states A and B. From A to B we'll be able to jump from state A to state B without any input, that is with empty input we'll be able to transfer from one state to the another state. So that is epsilon transitions. So now we will be discussing about how a simple regular expression is being converted to epsilon NFA. So for example, consider a input AB. So this AB, how in epsilon NFA it could be represented is very simple. Here we will be depicting is from Q0 we will be able to transfer to the another state, we say with A input. And next, for example, you say we'll be able to jump to next state. So in between this A and B transition we can have empty transitions. So or without this transition also A and B is possible, but in epsilon NFA this is also correct. A, an empty transition to Q2, and from Q2 to Q3 with B input we'll be able to transfer. This is also right. So next we'll see how A or B is possible in epsilon NFA. So here we will be considering a start state which says Q0, start state. From Q0 to Q1 with empty input I am just going on, and again from Q0 with empty input I am going to Q2. So now from Q0 with A input I am reaching the next state, and from Q2 to Q4 I am reaching with B input, and with empty transitions I will be reaching Q5, which could be the final state. So this is the general representation of A or B in epsilon NFA. So next we will just consider A plus. So this could be represented as, so the regular language for A plus is that without empty we will be having any possibilities of any number of possibilities of A. Just goes on. So for this I am just having, considering a state Q0 with Q0 to Q1 I am just having an empty transition, and I am going to Q2 state over here with A input, and again I am going to Q3 state with empty transition. So with this particular DFA I am just able to achieve A alone. So for suppose you want assume that I want double A, what I have to do is nothing but from Q2 to Q1 I am just putting another transition for A. So empty A, again A, and just goes on. And instead of A here, if we put A we will be getting only 2 times A. So instead of A I can just make a transition from Q0 to Q1 with empty input. So empty A, again when I have empty I will be able to come to Q1 state. From Q1 to Q2 again I will be able to achieve another A. So which says when during an empty transition from Q1 to Q1 I'll be able to make another transition from Q1 to Q2, and from Q2 to Q3 only I'll be able to reach the final state. So once you reach from start state to final state only you will be able to achieve a particular state. So by inserting an empty transition here I'm just moving to Q1, and from here to here I'll be able to achieve another A. For example, say for 3 times A, empty A, again empty is inserted, I'll be getting another A over here, again empty, another A. So 3 times I'll be able to achieve A here, and again empty which comes to final state, so I'll be getting triple A. That's all. So and next one is A clean closure. So this is very similar to the previous example. Here the only difference is that I'll be having empty here. Instead of multiple times A repeated again and again, I'll be having another empty over here. So we'll be writing the same automata for a clean closure, but the only difference could be I have to get empty here. So for this, so Q3, the same figure I am depicting here. That's all. So with this in Q3 I'll be able to achieve A, double A, triple A, 4 times A, 5 times A, and it just goes on. But in addition to all these answers, I want another empty over here. So that empty should be only from the initial state to final state. So here the initial state is Q0 and final state is Q3. So very simple, from initial state to final state I can just make an empty transition which says from starting from Q0 to Q3 when I reach I'll be getting empty. That's all. So these are few basics Epsilon NFA for the strings such as AB, ARB and A plus and A star, that is A clean closures. That's all. So with these examples I'm just going to depict here how A or B closure A, B, B string can be achieved. So here for A or B, first we have to draw the figure. For A or B, as we have told, we'll be having first an empty transition, and then after which we'll be having A transition and B transitions here. With this we'll be able to reach here. So here all we'll be having empty transition. So this is the general ARB figure. For this ARB figure I want clean closure. So when you want a clean closure, you have to insert a state before and after this ARB. So make this to be empty transitions. That's all. So for achieving only A, we had these two states alone, and when we want A plus, what we did, before and after we have inserted a states and they given empty transitions, and we have done. So similar to that here also, this is our ARB automata. So before this ARB automata we are going to insert a new state, and after this ARB we are going to insert an empty state with epsilon transitions. So for ARB closure we'll be having from final state to initial state of ARB we'll be having an empty transition, and newly inserted states will be having empty transition. So I'm just going to make the same figure over here, that is this is ARB. So ARB end state is this and ARB initial state is this. So from end state to initial state of ARB I'm just making an empty transition, and newly inserted state is this. So and newly inserted final state is this. So in this we will be making an empty transition. So as a whole this part is, so this part is our AR, this part is our ARB, and this part over here is our ARB closure. So with this we have achieved ARB closure, and then we will have the product of ABB. So the product of ABB can be given directly with A, B and B. So this also can be extended with epsilons if necessary. According to the question which is given to us, or application what we are using, we will just make the empty transitions, or ABB can be written directly like this. That's all. So after this we will just give the numbers for it. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So here the start state is our 0 and our end state is our 10. This is our final state. So, thank you.